In this series, you have to figure out the series first. They gave you ln, a number divided by square root of a number. They have 2, 3, 4, 5. This one, I will just let n starts at 2. So this is easy to figure out. So that one, you have to be aware that that starts from 2 to infinity. So when you write the function and the domain, you have to say for x greater than or equal to 2. And then you have a square root of n and then ln n. All right. And then the function is f of x equals to ln x divided by square root of x. And then we have to say the function is positive for x greater than or equal to 2. And then you may pause for seconds to think about it. Okay, x is positive, the square root of 2 or bigger is positive, and then ln 2 or bigger is positive. So you have positive over positive. So the function is positive. Okay, that is the first check. And then the function is continuous for x greater than or equal to 2. That is check, right? It's continuous. You don't see any vertical asymptote for x greater than or equal to 2. Okay, and then for the decreasing, you need to use quotient rule. Quotient rule is when you have a function divided by another function, you take the derivative of that. That is gf prime minus fg prime divided by g square. And then the derivative of this function, and then you square the denominator, that gives you an x. And then g is the square root of x, derivative of ln 1 over x minus function, and then times the derivative of the square root, you have 1/2 x to the negative 1/2. And then you do the simplification. After all that, you will have this 2x to the 3 over 2, and then 2 minus ln x. That is your derivative. So for x greater than or equal to 2, x greater than or equal to 2, the denominator is always positive, and then 2 minus ln x anything greater than 2, that will give you a negative. So we can say the function is decreasing when x is greater than or equal to 2. So for the check, positive, continuous, and f is decreasing. So check, check, check. And then now you can use your integral test. So that is integral from 1, oh not from 1, from 2 to infinity. I have ln x divided by square root of x. This one is integration by parts. Let me set up the improper integral. B approaches to infinity from 2 to b, and then ln x divided by square root of x dx. So this one we will be using integration by parts. So integration by parts. That would be uv minus the integral of v du. uv minus integral of v du. Okay, I am going to let u equals to, when you do integration by parts, never take the integral of ln. Once again, when you do integration by parts, never take the integral of ln. U is equals to ln x. I will take the derivative of that. Du is equals to 1 over x dx. Done. And then dv is the leftover. You took ln x, right? And then the leftovers are 1 over root x and also the dx. Oh, I forgot the dx in here. And then v is equals to the integral of that, the integral of x to the negative 1/2 dx. So let's move this up. That is equals to x to the 1/2, and then the reciprocal is 2. Following uv minus v du, you have 2 root x ln x uv minus the integral of v du, integral of v. The du is 1 over x dx. And then what do we have in here? Let me use this color. What do we have in here? And then this one is integral to 1/2 minus 1. That is x to the negative 1/2. And then you take the integral of that. That is x to the 1/2. 2 times 2 is 4. Okay, and then we have to set this equal. So 2 root x and then ln x minus 4x to the 1/2. 4x to the 1/2. Okay, since I already put the x back, at this stage, I would like to mention the limit again, because that is part of your presentation. Limit as b approaches to infinity. This one goes from 2 to b. Should I do another step? Because I want to avoid having like an infinity minus an infinity. Okay, I see a 1/2. How about this? I will do a limit as b approaches to infinity. I will factor out a 1/2. And then I have 2 ln x minus 4. How's that? Minus 4. This 4. Minus 4. And then I have from 2 to b. How's that? And then you plug in infinity. That is square root of infinity. 2 ln infinity minus, and then a minus a 4. All right, and then subtract root 2 and then 2 ln 2 minus 4. How's that? And then this piece gives you a big infinity. And then minus that quantity. I will just duplicate that. It doesn't matter anymore. And then this turns out is equals to infinity. Okay, I want to use the same color. That is equals to infinity. So what do we have right here? So we have a summation. Copy. And then paste that right here. We have a summation. This summation is equals to this improper integral. Copy. And then I should draw an equal and then put this right here. And then it turns out that the integral is equals to infinity. So we have an infinite sum. Therefore, the series diverges by the integral test, because the area under the curve is infinity. So the series diverges by the integral test. Okay, I prefer to do one problem in each video, so that is all the work for this problem. And then I will see you all in the next video for another integral test. Okay, I will see you there.